Welcome back. We're going to start off and jump right in with SineLaw, and this is trigonometry of acute triangles. We're going to start off with our learning goals, which is to determine the measures of sides and angles in acute triangles using the SineLaw. A sample problem would be in triangle ABC, if A is 35 degrees, B is 65 degrees, and AC is 18, determine the value of BC. And it'll become a little bit easier to do as we look at the questions in this section. And visually, here are some key terms that we're going to look at. An acute angle is an angle that measures anything less than 90 degrees. So on this right side, we've got this 30 degrees here, which is an acute angle. An acute triangle is a triangle where all the angles are less than 90 degrees. On the other side, we've got an obtuse angle, which is an angle that is between 90 and 180. And here's an example where 150 is between 90 and 180, therefore it is obtuse. SineLaw works like this. We've got a triangle and we've labeled it based on this here being angle A, angle B, and angle C. I represent those as being capital letters. And across from each vertice or angle, it has a lowercase letter. So this here would be side length A, which is across from angle A. This here is side length C, which is across from angle C. And this here is side length B, which is across from angle B. And what SineLaw says is that if we take the side length over the sine of that angle, it's going to be proportional for the whole triangle. So A over sine angle A is equal to side length B over sine B, angle B, and side length C over sine of angle C. And the reciprocal also holds true. This here is our first question, and we're being asked to calculate the value of C, which is a side length. And so I always teach my students to start with the thing that we want to solve. Here's also something which is usually very useful, is that we can circle the pairs of angles that match with the side lengths. So here we've got C, should be a lowercase c, C over sine of the angle C, which is 105 degrees, is equal to the other one that we have a matching pair for. We can't use A because we don't have angle A or the side length A, but we do have 7 over the sine 35. And how we solve this is we want to isolate for C. So this sine 105 comes up, and C is equal to 7 over sine 35 degrees times sine 105. And using our calculators, this would tell us that the value of C is approximately equal to 11.788. I guess I should use proper mathematical notation. This is approximately equal to, because that will probably be an irrational number. In this question here, it's asked you to find both value of A and B, and I'm going to encourage you at this point to pause the video and try and do this yourself. So here's what I know. I know that I'm going to circle my pairs. I know that I have 10 in this angle 116. I know that I've got A. I need to find this A, and I've got 33, and I know that I got B, I've got 31 degrees. So if I want to solve for A, I'm going to start with A over sine 33 degrees. The one pair that I have both numbers for is 10 and 116. It is equal to 10 over sine 116. Bracket. A is equal to 10 times sine 33 degrees divided by sine 116. And if we use our calculators, we're going to find that A is approximately equal to 6.06. If you're not getting these answers that I've gotten in the past few slides, double check to make sure that your calculator is set on degree mode with a D, not RAD, not GRAD. For radians or gradients, it must be in degrees. which is usually represented by your calculator as a D or a DEG. So we found we found side length A. Now we have to find the side length B. B over sine of 31 degrees is equal to what the pair that we have, side length 10 over sine 116. And so B will be equal to 10 times sine 31 degrees divided by sine 116 degrees. And using our calculators, B is approximately equal to 5.73. In this case, we're asked to find angle C, which is this angle down here. Whenever I'm finding an angle, I always start with sine of that angle first, and what I also do is I match up the pairs. So here's a pair that I'm working with, here's a pair that I'm working with. So I know that I've got the two numbers, so I know that I'm going to be using these numbers here. And I start with sine C, that's what I want to find, over its corresponding side, which is 145, is equal to sine of 37 degrees over the side length that corresponds to is the 174.53. I've probably gone to 2 decimal places to make sure that the number comes out nicely. This 145 comes up. Sine C is equal to sine 37 degrees over 174.53 times 145. And sine C is equal to, get out our calculators, and this should be equal to, or pretty close to being equal to, 0.5. To calculate and to move sine over to the other side, it's the opposite operation. C is equal to the sine inverse of 0.5, and C is then equal to 30 degrees. Moving on, here we've got example 4. I encourage you to pause the video at this point to try and do this on your own. And this is where we're going to circle the pairs, A and 30 and 18.312. Sine A is the angle that we want to find over its corresponding side over 30 is equal to sine of 30 degrees divided by 18.312. Sine A is equal to, bring the 30 up, multiplies the top, is equal to 30 times sine 30 degrees divided by 18.312. Get out my trusty calculator and see if we can figure out this is going to be sine A is equal to 0.819. So in this case, A is equal to sine inverse of 0.819. A is equal to 55 degrees. Well, I'd like to encourage you to look at something. This isn't something which is required us to learn in this level in this grade of math. But if we look at this is 55 degrees, and when we look back at our triangle, it definitely looks like this is more than 55 degrees. In fact, this here is an obtuse angle. And again, let's just see why this happens. Whenever we use sine inverse of a function, it will always spit back the acute angle. And that's also why when we look back at the very first slide, our unit is focused on acute trigonometry of acute triangles. So just to extend a little bit further, to have a bit different of a look, let's see what's happening and why that happened. So this here is our triangle, and this is what we call the ambiguous case. The ambiguous case, or ambiguity, means that there's more than one interpretation. So what actually happened is, when we have this angle side, this side length here is the same as this side length here, and it swings around. We have this other triangle where it is an acute angle that's happened. and therefore when we used our calculator it gave back this 55 degrees, and it thought, hey, I'm going to calculate the angle as though the triangle looked like this bigger one here, and it always will give back the acute angle whenever you do sine inverse of something. So the ambiguous case works something like this. When two triangles can be created with the same information, sine inverse always returns the acute angle, and the obtuse angle is actually 180 degrees minus the acute angle. So if our acute angle was 55, then we would have gotten, actually our answer would have been 180 minus 55 degrees, which would then say that angle A is 125 degrees. Again, this isn't something that you need to know in great detail or how to solve at this grade, but you will be expected to solve it next year. And it just gives you a bit of insight into what's going on and why it happened. Thanks for watching. Here's your classwork/homework, and practice will make perfect. I encourage you to practice. The more that you do these, the easier it will get. Thank you.